In this video, we're going to talk about using the limit laws to evaluate limits analytically instead of looking at the graph or looking at tables of numbers related to functions. So first off, I want to talk about a couple of basic limits. Those basic limits, the very first one is this rule here. The limit as x goes to a of a constant function, just a number, is always equal to that constant itself. So here are a few examples of that. If I have the limit as x goes to 9 of the function 3, well, that just equals to 3. And there's nothing special about the 9. Any value here for the a of a constant function is just going to be the constant function itself. And the reason for that, if you take a look at the graph of a constant function like this one, 3, well, look, the y values are all equal to 3, right? And so it doesn't really matter what x approaches to, the y value is always going to be equal to 3. So, all right, so the limit of a constant function is just that constant function itself. The next basic fact about limits is the limit as x goes to a of the function x is equal to a itself. So again, that's not hard to see why that's so. If I take a look at the function f of x equals x, and I look at some points on that function, it's not hard to see that every single point on that function has the same x value and the same y value itself. So whatever x approaches, right, the output, the y values are going to be exactly the same. So as x approaches 9 of the function x, the y values are exactly the same as the x values, so the limit is going to be 9. Here the limit as x goes to 5 of x is equal to 5, and so on. So those are some basic limits. So with those basic limits, then what we can do is put those types of functions together using the operations of addition, subtraction, multiplication, and division to make more complicated functions and more complicated limit problems. And those are really what I'm referring to when I talk about the limit laws. So here are the limit laws all together. The first limit law says the limit as x goes to a of a constant times some other function is that constant times the limit, as long as that limit exists. And that's a condition on all of these limit laws, is that the individual limits have to exist. And by exist, what we mean is it has to come out to be a number answer here. So here the limit as x goes to a of f plus g or f minus g, right, is going to be the limit of as x goes to a of f of x plus the limit as x goes to a of g of x. So the limit of a sum is the sum of the limits there. And same thing with subtraction. If I have the limit of f minus g and I know both those individual limits exist, then I can say that the limit is going to wind up to be just the subtraction of the individual limits. For multiplication, limits work nicely here. Here I have the limit of the product or multiplication of two functions. And so when I multiply those, or the limit of that function is just the multiplication of the limits there. So all of those work really nicely, about as nice as you could hope to have there. So, and the last one here on this one that we'll talk about is the limit of the division of two functions. So if I have the limit of a function that's built out of two functions being divided together, what I can do is just take the limit of the top one and divide by the limit of the bottom one, provided that the bottom limit doesn't equal to 0. If it equals to 0, the bottom limit, then we have some problems and the limit laws aren't valid. And some of the other limits that we'll talk about, or some of the other techniques that we'll talk about, are what do you do when you have 0 on the bottom of a quotient like that. So if the bottom one's 0, then you're going to have to do something else, because these limit laws do not apply, or at least this one doesn't apply when the bottom limit here is equal to 0. So those are the statement of the first few limit laws. In the next couple of videos, we're just going to take a look at how you would apply these limit laws to some limit problems to compute the limit.